Okay. I'll try and share. Please let me know if my screen is visible now. It's a PPT.
Yes, madam. Share, please. हाँ.
Can you see the PPT?
हाँ हाँ हाँ.
What is written? Can you please tell me?
No, ma'am. PPT is not visible. Document.
Okay.
No, sir. Doc file is document Word file is open, ma'am. PPT is not yet shared.
Okay. Okay. Okay, let me get some help from somebody here. My PowerPoint is not showing on the share window. Can you tell me the reason why?
आप ना ये वाली स्क्रीन को मिनिमाइज करिए, आप जो अभी करंट में ओपन की हुई है डॉक फाइल को आप मिनिमाइज करिए.
Yes. Yes.
हाँ, अब आप मैडम ना आप एक काम करिए, एंटायर स्क्रीन शेयर के ऑप्शन में जाइए और एंटायर स्क्रीन शेयर करिए एक बार.
ओके.
शेयर में एंटायर स्क्रीन का ऑप्शन देखेगा एक.
हाँ है.
हाँ.
ओके.
हाँ, अब एंटायर स्क्रीन शेयर करिए.
It's in process.
हाँ मैडम, अब ये स्क्रीन करंट स्क्रीन को मिनिमाइज कर दीजिए.
ओके. यस.
हाँ, आप अपना पीपीटी ओपन करिए और नीचे टास्क बार में. हाँ हाँ.
कैन यू सी द पीपीटी नाउ?
हाँ पीपीटी विजुअल मैडम. ये एक सामने आइकॉन दिख रहा है, इसको क्रॉस कर दीजिए. आपके जो सामने मीटिंग का आइकन दिख रहा है. हाँ, इसको क्रॉस कर दीजिए. हाँ कर दीजिए.
ओके. इज दैट ओके नाउ?
स्लाइड शेयर मोड पे मैडम एक बार क्लिक कर दीजिए.
कई बार स्लाइड शो पे ये ना इन्फिनिटी मिरर देता है, तो आप मुझे बता दीजिएगा ठीक से दिख रहा है?
नो प्रॉब्लम. नाउ ओके मैडम, एवरीथिंग ओके.
ओके, ठीक है. तो मैं वीडियो बंद कर दूं क्या, कि आपको क्वालिटी अच्छा आ रहा है?
नहीं ठीक है, कोई इशू नहीं
आ रहा है, क्वालिटी अच्छा आ रहा है. ठीक है. So thank you, Meadow Agriculture, for giving me this platform for interacting with so many learners of our program. I'm sure many of you would have learned today and before today many aspects of art. It has multi-dimensions, but majorly we want to do art because it is an easy interface. Now, there is always a discussion among academicians whether it is a software or whether it is a coding language. However, it is a blend of two. That means it provides you with ready macro constructs, with ready built-in program bunches for statistical aspects. So that, as I heard in the previous talk, I had joined a little early, you were able to do skewness and kurtosis. You were able to do some bar diagrams. This much I could see at the end. So you need not understand what bar diagram is, and you neither need to know the program construct. So this is one advantage of art that has made it very useful and very popular. The second reason is, nowadays, people want to work in Stan and Python. Sometimes they also have Winbugs, INLA, and higher statistical concepts to explore. There also R has proved itself to be very useful. So I'll keep it in an interactive mode so that the candidates who are attending will let me know if they understood the concept. I'll move forward. If they have questions, they may stop me there and ask me. So I just want to know, since you've already gone through at least 2 lectures today, I want you to tell me through voice, because I cannot see anything else. My screen is open in front of me. Do you understand how to download R and where to get it from, the source from where to download R, and how to run the program? If you know it, any one person can say yes. Should I introduce this or should I skip this slide? Am I audible?
Yes, ma'am.
madam.
You can continue.
Okay. Should I tell you how to download R, or do you already know it? Should I do this slide or should I move forward?
No, ma'am, you can deal with the slide. No issue.
Okay. So since you know already how to source R and from where to download it, what is an executable format .exe extension, then you are able to see the script file. In script mode, we are able to type anything. It is very easy to work with R in the sense that you have a prompt in the form of a greater than or less than sign, and you have to type whatever command R understands, whatever language format from English R understands, you type it directly there. So we know that print means you have to, the R has to reproduce whatever is written inside the parenthesis, which is adjacent to the print command. So you see, I have tried to write it in an inverted comma mode, as well as you can try and do it without inverted comma mode. This you may try at home, or you wish to, you may try with me now. So while I'm teaching you, if you have your script file open, you may type it and tell me that whether you are able to do it or not. It is your choice. I'll speak very slowly. I'll give you pauses. And if you want, I'll give you some extended pauses and explanation on the related command. What we want to understand at the outset is, in R, it is not case sensitive. The command, as I've written on line number 1 and 2, are different in appearance, but they are going to execute anyway the same intention, the same objective. Then there is an assignment environment. Assignment means we want to have some variables, and in these variables, we want to place some values. Like in a print command, R has already placed some value. Some complex construct of instructions is already stored in the print command. Now I want to store something in a variable in a value name called y. So this is called assigning. Assigning means the end where you have the less than end of the inequality, that is the receiver. Where you have the greater than end of the inequality, there you have the assigning value. So y will receive the assigning value, and assigning value will be given to the receiver, which is on the pointed end of the inequality. That means I can also write like 7 dash greater than and then y. That means I can reverse it. So the next aspect I want you to understand is, very small values we round up, and then we get substantial errors. However, in R, we have a facility of using log command very directly, and when we convert it to log, that loss of fraction is saved. So usually in statistics, you will see that many a times we use logarithmic transform of the original data. This I want to tell you here, you will not find in any book why we use log transform and when should we use it. So number one, it is written here in point 4, when you will get values like 0.01 raised to power 200. That means you have very many decimal points. 10 raised to power minus 26, 10 raised to power 46. That kind of decimal values, they can be handled using log transformation. Those of you who are interested can try both the commands where I'm assigning values to P and to Q. You will understand that those who are doing mathematics, that both are different ways of representing the same quantity. And you will see that you will have higher precision, more decimal clarification in the second one. We use log values, log transforms, when the data has too much of difference in the lower value and the higher value. Because if you want to plot the same value where it will say minus 0.02 and say 20,000 on the same graph, you want to have a bar graph, then it is very difficult to see that small value on that same graph because of the dimension incapability. Therefore, what we use is, in statistics, the first rule is always look at the extreme values, the minimum value and the maximum value, and then try to use logarithmic transformation on the original data rather than working with the original data. In the, sorry, it should have been 5. I have written 4 2 times. This is data. Data is again a command where R understands that this data format, that is a group of variables, is available within its memory. So this is a very famous data set. It's called cars. If we write data parenthesis, and in the parenthesis we mention name of the data file that is already available with R, then it will just go and access that data set. Here I have tried to fit a linear model. So fitting linear model is most useful for the applied practitioners because you have already gone through 2 or 3 different R lectures today. Therefore, I am introducing linear model in my first slide. Linear model, the command is LM. Whatever type of model I want to specify under LM, I'll be assigning it to the variable small m. Earlier in point 3, my variable was small y. So m is the receiver. From now on, after the assignment, during the active form of this particular script file in which you are working, till you do not exit from it, small m, it will understand as having this linear model construction. So here, I have given a very small specification where the response variable is 1 and explanatory variable is also 1. DIST is the response variable and SPEED is the explanatory variable. So what we do is we assign R to model distance as a function of speed. Once we do that, computer wants to know where should I get this variable. So it goes to data and it sees that assignment is cars. So it has already invoked cars in the first command line of the script, data cars. So now it has access to cars. It knows that it has to work on this data file. In the LM specification, we are reinforcing to the computer that yes, you have to take data from the cars, which is already active in my current R session on the current script with which I am working. Then we ask them, because the computer now knows what is the linear model assignment. Now we want to see what computer has. So computer will give me the output. If I want it in the form of linear model, I'll get it. If I want it in the form of plot, I have to additionally give the command plot, and then RESID is for residual. Residual of M, it will give me the error in fitting the original value of the variable and the fitted value of the variable, which is that it has fitted using LM command. It will take pairwise difference of the actual values in the data file car and the computed value through the LM command. And all these values will be stored in the variable RESID, residue, this is the command, and RESID M. In this it will be stored. So once you see the deviation between the two values on the plot, you understand that more the distances, more the ill-fitted linear model is for the data. So what we want to understand as a summary of this slide is that the softwares produce a lot of output. It will generate a lot of output because it has been trained to do that. However, I have to decide what piece of information is important for me to further continue with the analysis. If you want, you can run this LM command, and if you wish, I can continue further. Would you like to run LM command while I'm waiting with you? Okay, so I continue. This is a little for your knowledge. You may or may not know this, but it was introduced very early. In 1933, the first experiment took place. They were trying to do something, and then later on in 1980s, it had gained traction. And then later, after 2000, R became very popular. And it is a freeware, but still, yes, somebody. I can. I cannot hear you. Do you want to say something?
No, madam, no.
Okay. So, who is handling our core team? As I told you, after 2000, it has gained a lot of people who are contributing to this. Peter Dalgard, he has contributed a lot in the Bayesian dimension, and others have also done a lot. There are many more names. I have selected only few names here. And these people, if you just Google them, you get their emails, and they respond to the email queries. You are getting stuck with your program. They are very kind enough. Each of them, they respond how to meet your output which you are interested in for your analysis through R. They help you a lot. So these are a few reasons why we should use R. On this slide, you already know how to run. This will help you. Maybe you should copy this, or later on when you get the PPT from the organizers, you may want to always keep what I have written here on slide number 8, how to get help. So the topic on which you want to get help, that topic has to be written in the parenthesis. Question mark is also a substitute for command help. So R is very user friendly. It has an interactive interface. Sometimes you don't want to ask anybody, then you can go for this and you reach the help wherever you want to help. Now, I would like you to read this carefully. Anybody who has any question can ask you. I will be quiet for some time and then I will speak again after 1 second, 2 seconds. So if you want to do histogram, for example, and you don't know how to do histogram, then the second bullet will help you. You write find, and in the parenthesis, at present I've left it vacant. You write find histogram. Then it will tell you where that package is from which you can source histogram. And then it will also tell you how to use it. So these are, in the fourth bullet, I have written examples. If you want to see how on a certain small workout exercise, they compute mean. Mean usually applies to arithmetic mean in R. Mean, median, geometric mean, harmonic mean. These are 4 other types of means in statistics. However, if you type mean, you get help on arithmetic mean. So this fourth bullet is also going to help you a lot when you are doing your work alone and you don't have any other person who knows more about R than you. Then you can just simply type on the R script file examples bracket mean, for example, or correlation. It will give you a small example there where you can understand what data it is using and how it is computing correlation. So these are, or you can use demo, either examples or demo. In demo, it will give you breakup of the how that example has to be concluded. So these are the little points on slide number 9. When you're working alone, you can get help from. Graphics is very important for applied statistician means people who are using data, but they are not from the field of statistics. So this greater than sign, it has a name. It is called screen prompt. Now, whenever you run something, it gives you, R gives you your result, and then it again starts blinking this screen prompt. So what is name of this? Screen prompt, number 1. Number 2, what is it saying? It is saying, what should I do next? Right? What now? What you want me to do? Sometimes you see on the first line of every row a plus sign. So when you have a plus sign, it means that you are continuing from the first line to the second line. Sometimes you have 4 plus signs on the first column of each row. Then you understand that the sentence is not complete, information is not complete, it is continuing in the next 4 lines. So plus means this, okay? So the prompt, screen prompt, you understand like this. You can also, earlier I told you to use an assignment variable like y. But if you don't want to use it, you can directly write your command on the screen prompt and you can get answer. There is this box bracket and it gives you number 1. If there is only one row which contains the answer, it will give you number 1 only. But if you have given it multiple tasks to perform on the same screen prompt, then each output will be displayed on a different row and each row will be labeled as 1, then sequentially 2, 3, 4 and so on. In the end, I have tried to show you another example where I continued the command on the next line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, You may read it. I'll give you 2 seconds. Please read this. If you have any questions, you may ask me. This will help you when you are working alone. Arrow key means you have a keypad on the desktop or laptop. So if you press up key or down key, you get the command which you had asked the screen prompt to execute 1 step or 2 step earlier. As many times you press the key, as many steps earlier you reach. And as I said, you invoke some variable name in the current script session, or you assign a new name to a bunch of commands. Then it is a good practice to remove variables, RM, so that in the next session, R session, you can reuse that variable for some other assignment. These are well-known operators. I have used the first operator earlier in my examples. I'm using here unary minus and plus because, as I told you just now, that a plus sign will appear at the beginning. This plus is unary plus. It does not require 2. It just shows that we are continuing. Modulo means you are looking only at the absolute value. We are not interested in the direction, whether there is a minus value attached or plus value attached. Direction is not important. Only the magnitude is important. These are some more operators. Assignment right to left is what we do usually. Assignment left to right also I have explained to you earlier. Would you like to try sine, cos, or log that I have written here? It can be interactive if you want, or I will proceed further. Okay, so when you're working alone, please try slide number 13 and see what you get. If you have any issues, you can WhatsApp to me. Data types. So assignment operator, if it is a single value, can also be an equal to sign. And we just type the variable name and press enter, we get what value it contains. This particular slide number 14, I want you to understand that if there is an existing variable name, which this current session of script file are, it knows. Then you have simply to write, and you've forgotten perhaps, or you want to recall the value, you can simply write name of that and press enter. Sometimes I want to assign a new variable, say u, to my next bunch of command, but I've forgotten whether I used u in the current session or not. This is a good way of finding out. Now we slowly proceed to complicated ones. From a single value, we come to a group of values. A group of values are important because, for example, you are from agriculture. So in agriculture, every year on the same plot of land of rice, we get different amount of outcome in tons or in metric tons. So you want to write 9 metric ton, 8 metric ton, 5 or 2, right? So you are looking at different years, 4 consecutive years. So you have to work in group. Data means a group of values. Unless we are working with group of values, statistics does not have much to do. So we come to a group of values now. For that, it's called concatenate. C means concatenate, means you have to bunch them together, separated by simple comma separator. This is how it will work. It will just, when you write marks, because you have earlier assigned it like this, marks has been assigned 9852. You want to know what marks means here. So you get, this is what your script, our script understands that marks means. Now from vector, we want to come to matrix. So matrix has a concept of rows and columns. If I assign matrix that n row, number of row is 2 and number of column is 4. And this row and column number has to be applied on the first assignment of matrix, which is vector. Vector has to be assigned earlier using concatenate command. So first you are giving it in a form of vector. Then you want to rearrange that vector in a matrix format. In the matrix, you assign simply the vector, the name of the variable where the whole group of data exists. Then you want to tell the computer how many number of rows and how many number of columns you want to arrange it in. It will start from left. Arrangement will be started. And first it will arrange your column. And then it will arrange your row. So 1 and then 2 will come in the column. Then 3, 4 will come in the next column. Okay. However, you don't want it, then you have to negate whatever it has by default. By default, it has arrangement by column. So if you want to negate it, you have to add one more assignment, one more specification here. That specification is called by row is true. In place of by row is true, you can also write by column is false. True and false are logical operators which are known to the R script. If you have any questions here, please ask me. Otherwise, I'll proceed. I'll give you 1-2 seconds. I hope you have understood assignment of a single value, assignment of a group of values through concatenate, and assignment of group of values. After that, you want to arrange it in a matrix form, in a grid form. Then you have a command called matrix, but there you have to be careful that number of rows multiplied by number of columns that you are assigning should equal the number of entries that you are entering in your vector assignment. Sometimes these values, we don't want them as numeric values. We would want them to be high, medium, low, less, more, or maybe fair, good, excellent, categorization. So when we don't have numeric assignment, but we have different groups, we call it either as nominal or ordinal. Ordinal has this feature that one is greater than other. One category is highly placed than other category. There is a concept of comparison. That is ordinal group. In nominal group, there is no comparison. For example, lizard and snake, there is no comparison. But height of lizard and height of snake, there is comparison. Length of lizard, length of snake, there is comparison. So we have to see when we are using non-numeric variables, then actually they are factors, and these factors cannot have numeric values. Still they can be compared ordinal. They can never be compared. None of them is superior to other or inferior to other nominal. So this is how you will do it. Any questions? I give you 1 second. You may read the slide carefully, please. So first I have to do the assignment using equal to operator, and then I have to make computer understand that these are non-numeric values, and therefore I have to use the term factor with it. So when I'm using factor with this variable, I have to give it a new assignment so that the computer understands that we are dealing with levels. You may read this carefully, please. Slide number 19. In place of by row is false. It is not usually required because by column is true. That is the default. But I want you to understand what it means. Should we proceed assigning the value to the columns or to the row for the next value? This I wanted you to do hands-on. I'm not sure whether you're ready because I'm not getting any response. However, if you want, you may. Otherwise, you may simply read it carefully and do it on your own when you get the slides. Any questions, please ask so that I know I'm being heard.
Participants, please respond.
Okay, so I understand you may have done it in the earlier lectures. And slide number 20, this is supposed to be your hands-on. So if you want, you can do it later and contact me for any clarification individually through my WhatsApp. This is your hands-on assignment. Earlier, if you notice, the row number, name and column name were written like comma 1, comma 2. So that is by default R understands. However, I don't want it to look like that. I want to give these some names. These are called dimensions. The row heads and the column head. There are 2 dimensions, row and column, and each must have their name. So for that, I use row names and col names. How to do it? In the dim names, I have used it here. In the example, 6th line, dim names. A is the assignment for matrix. So when I say list drug and trial, then drug is given the name of drug. Each row head has a name. I'm naming the rows. Instead of just writing comma 1, comma 2, it will replace that default with these names. So this is very good for your own presentation of the matrix. So this again, slide number 21 is supposed to be your hands-on. If you are comfortable now, you may do it. If not, this is your exercise. You may do it later. I'm giving you 1-2 seconds again. Go through the slide. You want to ask me any questions, please ask me questions related to this slide now or to any of the earlier slides. Now we come to a more sophisticated form, a data frame. Data frame can have numeric values, which we were doing so far, but it can also have string values, text values, calendar values, logical values like true or false. Each column of data frame is called a vector. vector, all data elements must be of the same form, either numeric or non-numeric. And they should have the same length so that the matrix is of the same format. This is another example where I try to demonstrate. Again, this was for your hands-on, exercise for hands-on. If you are comfortable, I'm giving you 2 seconds. Please do it. Just copy what I have written. And if you want more time, please just tell me here. I will wait more and help you while you are doing it. So this is a data where there is a city. All these cities have a certain nature. They are all urban in nature. So that we are trying to specify in the data frame. We are giving name to the variable city. And there is income, 2 types of income, one lower group and one higher group income. So this is how you can arrange. Please read this carefully. Then I will speak. I'm giving you 2 seconds to read it. This will help you when you are doing your own data analysis. When you have your own data, and you, of course, everybody wants to arrange their data in matrix form to make it more meaningful. This slide number 25 will help you. When you want to regroup your data and show new results. The concept of packages. So most of us, we want to do graphs. So ggplot is a very good, ggplot2 is an improved form, is a very good library where you get all kind of graphs, bar diagram, pie diagram, histograms, line plots. So it's very important you do ggplot. So these are groups. These are different rooms inside the R package. And in different rooms, we call it library. And in different libraries, different type of data, different type of commands are stored. You want to simply use that command, then you have to write name of that command here through library, so that that particular package could become active in your current R script session. So library mass, library, then you have to attach this. Within mass, there is a group called bacteria. So you have to attach that bacteria. And then fix means you have to keep it here in this R session till I ask the current R session to detach bacteria. Till then, this will remain active with me till any length of time. For example, if I want to keep my session alive for 4 days. So once I fix it, it will remain active for 4 days. The last line is fixing. So this I have done actually to help you do the hands-on, but I think you're not comfortable doing hands-on, no? So you can just create a small data set of 5 people where you write 5 names from your friend circle or family, then you give their age in next column, then you give their age in the give their gender in the other column. For this, you will have to use data frames. And in the beginning, it will take time. And then you have to fit this LM model, linear model. So these are small examples on page 27. Till now, whatever we have done, you understand how it can be rearranged for different type of data. So whatever data you have with yourself, then ultimately you know that yes, I have to come till page 27, whatever type of data you have. You must try and do linear models. For linear models, you must, whatever uh, variables you have, raw variables, you have to first arrange them in rows and columns, arrange them in data frames, and then come to linear model, which I had introduced in the first slide because I wanted you to understand that you are doing statistics and taking the help of R because you are interested in relationships among the variables with which you are dealing. For relationships, LM is the only solution for the initial data scientist. Later on, there are many, but initially, it is a must that you do regression, simple linear regression. The key to it is simple, LM. I have used this many times, sleep.sys function till you press enter. Your next, I've used in the current PPT also, till I press enter, my next floater is not available on the screen. So this makes my presentation very dynamic, and sometimes the listener, they just doze off, they forget what they are looking at. So this happens because human mind is tuned only to stay active till 7 or 8 seconds. After that, it drifts off. So to bring people to come back, you have to show some movement on the slide. For that, this sleep.sys function is very important. It brings something dynamic which moves on the screen, and the people, they get alert. Please read slide number 29 carefully. What is control flow? That I will tell you. See, flow means algorithm. Algorithm means a sequential step to be followed. That means first I get up from my chair, then I walk to the door, then I open the door. This order cannot be changed. I cannot open the door while sitting at the chair and not walking in between. So sequential steps is very important. This sequential step through flowchart is given to the computer. So this is control flow. Now, if, then, else, this is the control command in all computer coding language. So this is the control flow. It also loops us back to the original format. Sometimes what happens is we say if, then do this, else you go back to the earlier one, right? So sometimes looping is there. Looping means going back to the previous step. And then again follow the same forward sequence. Please read this carefully. This is how I'm going to build up on my next few slides. You can see now I've started using very freely the plus operator on beginning of each line. Because now I know that you know what it represents. So we are using relational operators here. When we are doing the conditioning, conditioning means you have to see some relationship. The relationship is either, as I said, higher or lower or equal. So when you are doing conditional statements, these relationship operators become very important. I've shown some relationship operators earlier, modulo, negation, and 2 false logical operators. So first, I've taken a small example. Again, this is supposed to be your hands-on exercise for today. But in online teaching, this is the barrier, that because I cannot see you, I do not understand whether you already know this and you don't want to do it, or you're finding it difficult and don't want to do it. That I do not understand in online medium. Therefore, I'm trying to help you as much as I understand you. So what I have done is I've used 2 variables, x and y, assigned it directly using equality operator. So if you give a simple value 6 and 2, so you can simply see if x is less than equal to y, then outside without then you can write z equal to x plus y. If this is not true, then it will say z not found. This condition is false. So nothing has happened. However, if you reverse the argument, then it will give you the answer. So sometimes we misspecify something, then also we can have this error, or sometimes we actually want to see whether it is doing it the correct way. So here I have used the latter argument. I want to show you that yes, it is doing it the correct way. Now we had if statement earlier. Now we have if else statement. Please read it carefully, the first paragraph. You see, usually you are using if then. However, in R, I'm just using if because I have a parenthesis argument there. Okay, so I come back to next slide where I want to introduce else, if else. Please read carefully the first paragraph. Now we must note that you are using 2 commands in the same construct. So when you use if, then you write the condition in parentheses and then you open a curly bracket and write all the conditions that you want here and then close that curly bracket and then write the statement else and again open a curly bracket, write your group of conditions, close that curly bracket also. So this is a new thing. I'm gradually developing the context of R. Please be alert. It's night time, I understand. I'm encroaching on your dinner time, perhaps. Now I come to looping. Looping means I told you, I'll go back to my earlier step. In the first statement, I said conditional means you are going in a sequential manner and you are moving forward. And now what I'm doing is I'm looping. I'm at some time point in future, I'm telling you to go back to the previous step and then come again, right? So this is called looping. Please read carefully. And there is a while. This is entirely different. While is a self statement. It does not rely on 2 build-ups. It just says you have to continue doing while you meet this condition. As soon as that condition is met, the flow is stopped. The program is terminated. Sometimes we want to repeat some particular group of commands. But we do not know what we are going to encounter in the data set. For that, we need to do some calculation. And we have to keep on moving along forward as long as we see that calculation condition is met. So while we don't need if else, we just use while, a single statement, depending on the use. Now I'm moving further in R constructs. I want to use a new loop called repeat. Please see this example. Slide number 34. It was for your hands-on. So please see, if you want to do it now, I'll give you more time. You can just tell me to stop. I'll not move further. Otherwise, just go through it piecewise, see how it is being done. I brought a lot for you today. At some time point, if you feel that you don't want to continue, you let me know. But learn as much as I cover with you. Try to learn later tomorrow morning. Any questions relating to this particular screen?
Hello, ma'am. Hello. Can you explain this slide? Repeat, please. Hello.
Hello, madam.
Okay.
Hello.
Hello.
Go on, or you have some questions? There's a lot of echo.
Can you explain this syntax? Hello.
So why do we use break statement? Please see, we don't want to go into infinite loop, right? Only way to terminate the repeat loop. Now see carefully where I have used break. If t is less than 2, then break. That means you move out of the program is finished, you have what you want. That means you are not interested in t which is less than 2, then you don't want to continue. Only if t is greater than 2, you want